Hello, this is Jason Kendall, and I'd really like to welcome you to my introductory astronomy lectures. It's a wonderful journey to go out and start the hobby of amateur astronomy, and you'll always have a really wonderful time no matter what, just going out and enjoying the night sky and seeing the stars and watching things move and watching things rise and set. You don't have to have a telescope, you don't have to have a camera, you just have to have some time. Go out well after dark, find a dark place where you can see a lot of stars, and just begin looking. That's the basics of observational astronomy. Get away from all the bright city lights as far as you can so that you can see pictures like this, which are the stars from Boulder, Colorado, that I took with a camera. Well, this is actually a couple-minute exposure, 60-second exposure with a DSLR camera. On August 16th of 2017, about 11 p.m. from the mountains above Boulder, Colorado. Boulder is the sky glow off to the side there, to the left, and we see some planes flying in of Boulder International Airport across the horizon. But what we do see, in addition to the tree in the foreground and some people's houses in the background, is we can see the Milky Way centered up, rising up from the horizon. That's not smoke, that's the Milky Way. Very often when people first see the Milky Way, they think it's smoke, especially people who have lived in cities their entire life. They just can't believe it when they actually see the Milky Way in the sky in a very dark location. But if you also go outside on such a dark night and are able to find such a place that's hopefully nearby, you'll notice that you get lost trying to count the stars. This image kind of tells that story where you could, if you scanned around the sky, you would probably find that you'd see 2,000 to 4,000 stars in a truly dark place. Most places in the urban are blighted by urban light pollution, but you can still find a number of places if you go hunting for them, and I suggest you try. What we see here is stars in the sky, the Milky Way. Just to let you know, behind the tree is the teapot shape of Sagittarius, and off to the right, the bright star straight up from the hill. It looks kind of reddish in between two bluish stars on either side. That's Antares, the heart of the scorpion, and the pinchers of the scorpion are almost to the edge of the screen to the right. And in fact, if you look at the two lights that are really close together on the horizon, the two almost bright yellow lights, if you look straight up from them, you see what looks like one of the brightest things in the sky. That's not a plane, that's the planet Saturn in the constellation Ophiuchus, between Sagittarius and Scorpius. When we look out in the night sky, we can certainly see quite a few things. So let's actually take a new way of looking at how to find things. Because let's say I was outside with you and we were stargazing and seeing this. How would I point out to you what Saturn is in the sky? We would have only two things to think about. How high is it off the horizon? And where is it with respect to the horizon? And that is what we call the altitude and azimuth system. Now I've clearly demarked Saturn with this green bar and shown its altitude off the horizon. And why does that go below those hills? Because it seems like the horizon should be the top of those hills, but it's not. It is actually not the top of those hills. And I've demarked due south there. Due north, straight north, is directly behind me. And let's now pretend that we can measure angles around. And so we can say, what is that angular measurement from the horizon, the green bar at the bottom, to the green bar at the top that shows where Saturn is? And how far around the horizon do we have to go from north, through east, through south, to that point from the left? So we can say, look at that altitude bar, the lower part, and go left. That'll get us to south, then east, then north. That will swing some angle all the way around. And that's roughly about 210 degrees around from due north. 180 degrees is, of course, due south. 90 degrees is due east. So we're going a little bit west to south, and that's 210 degrees azimuth. And that bar, the green bar, is about 21 degrees altitude. That just so happens that on that date, at that time, in that location, Saturn had an azimuth of 210 degrees and an altitude of 21 degrees. And this is what we call the horizontal coordinate system. And what I described was you find where north is, And north is towards the North Celestial Pole, or Polaris, the North Star. And then you simply face that on the horizon and slowly turn around, keeping your eyes level. And if you go 90 degrees, you'll be facing east, and that'll have an azimuth angle of 90 degrees. And if you go all the way around such that azimuth angle is due south, you'll be facing away from north. And if you keep going a little bit around again to 210 degrees, you'd be at the azimuth angle we saw in the previous picture with Saturn at 210 degrees. Then we would have to go up in altitude off the horizon, from the horizon, to say that star. But in this case, it was the planet Saturn, 21 degrees. This looks like it's more than 45 degrees to the altitude in this diagram, and it's not even to east. So this looks like it may be 45 or 50 degrees azimuth and maybe 50 or 60 degrees altitude here in this diagram. And why do we have this coordinate system? And what's with this dome sort of thing? And that's what we think of the sky. We think of the sky. We imagine the sky to be a dome over us, and that is bounded with a boundary of the horizon all around us. And that's our reasonable, normal way that we think of the sky, that it overreaches us and that we're under some dark dome full of stars or a bright blue sky dome. And that's what we think of as the celestial sphere or the sky. Now, if you lie on your back as the observer and look straight up, that point in the sky is called the zenith. And there are many points on the horizon. There's a whole circle. The horizon is a circle around you as the observer. The coordinates of altitude and azimuth make up what we call the horizontal or altaz system, and it is dependent upon the exact date and time and location on Earth that you are. In order, that star will have different altitudes and different azimuths at different times and different dates at different places on the surface of the Earth. Why is that? Because the Earth is a sphere and it's rotating and moving through space. So these stars are not going to stay fixed. That's right. You've seen the sun rise and set, you've seen the moon rise and set, you've seen stars rise and set. So therefore, they're constantly changing in azimuth and altitude. And if you were to call up a friend and you're in, say, Rhode Island, and you were calling up a friend in California and it was very late at night for you in Rhode Island, and early in the evening for the person in California, the same object in the sky would have a completely different azimuth and altitude, which would kind of make it difficult for you to explain where the thing is in the sky unless you have a different coordinate system. But if we're out together in a stargazing out on our back porch or at some dark location, we can always use the altitude and azimuth to help navigate around by eye, and because the stars don't rise and set fast. Nothing's swinging around as fast as it could. So that's very good for when you're right next to each other. All right, let's actually take a look now at of what we would do with these things. So we've got some stars in the sky. Maybe we want to, say, organize them. And so I've taken some snapshots from Stellarium, and when we look closely at this, we see, well, that there's just a bunch of stars in the sky. But we can then group them in particular ways called constellations. Constellations are areas of the sky with stars that form a particular pattern. And any of these patterns, like you see the belt of Orion there, the V of Taurus, and the V of Taurus isn't truly accidental, and neither is the tiny, tiny, tiny little group of stars called the Pleiades up there in the upper right. But definitely the box of Orion and the 3 stars of Orion, those are accidental. All those stars are at very great distances and would look different if we orbited it at 1,000 light years or so, as we are very distant from Orion today, and we swung 1,000 light years around it. The orientation of all these stars would change, and we wouldn't see this familiar asterism known as Orion. All constellations are accidental patterns because stars are at different distances and are not necessarily related to each other. I just happen to include the Pleiades and the Hyades in here, which are related to each other. And most of the patterns that we describe and think of as constellations have been used for thousands of years, and almost always are based on myths, except for the southern hemisphere, which are based on instruments, navigational instruments, and such forth. When we think about this, I've just now added the artwork of things that we might tell stories about the sky. And the stories we might tell about the sky are, okay, Orion is a great hunter, and he's hunting Taurus the bull. And he's backed up by the unicorn Monoceros and his dog in the lower left, Sirius, the dog star, Canis Major, is chasing the rabbit at his feet. There's all these kinds of little stories you can tell by imagining that these gods and heroes and animals are up in the sky. And these are this mythology that we speak of. And every culture has its own mythology across human history. It just so happens that the constellations that I'll describe to you are internationally agreed upon. And these particular constellations shown in this image are mostly hailing from ancient Greece. And Orion is a great hunter or warrior. But it's interesting in many cultures, very many cultures, irrespective of ancient Greece, but many cultures regard that pattern in the sky as a man or a warrior in the sky, which is really interesting. And it speaks to our ability to see shapes and things and a lot of our collective imagination as humans and what we think of and what are common things amongst all humanity. That's kind of a fun thing to think about. Anyway, so now what I'm going to do is I'm going to add the constellation lines to help describe where, now that we can trace out these things if we wish to by pointing them in the sky with either a laser pointer, or if it's 1,000 years ago it didn't have laser pointers, maybe just somebody looking over your shoulder where you point your finger in the sky as you do stargazing. And the constellation lines then would make up the image of that we see as this artwork. The artwork is not, of course, in the sky. You don't see that. And you don't see the lines in the sky. None of this is in the sky. Only the stars and the Milky Way and the nebulae are in the sky. So we're all imagining these lines, and we're all imagining this artwork, and the lines then trace out the mythological artwork that we see here. Now, the box that's around Orion, that is a particular kind of box. We might call it an asterism. And the V of Taurus, which looks like the tip of his horns and the eye of the bull, and that V looks like the head of the bull, that and his advancing feet make the two other lines, I guess you could make that. It's like a body and one advancing hoof. That's an asterism. It looks like the asterism of the horns of the bull. Typically, asterisms are of bright stars in a constellation. All right, so now I've added some names for some of these stars, some of these very famous names. Aldebaran is the name of the eye of the bull, and we have Betelgeuse in the upper left shoulder of Orion, the right shoulder. Well, I mean, house left, as it were. We're looking at Orion. But from Orion's perspective, stage left, I guess, stage right. But to the left is Betelgeuse, and to the right is Bellatrix, his other shoulder. His foot is named Rigel. The knee would be Saiph. And the belt stars have the names Alnitak, Alnilam, and Mintaka. And almost all the bright stars in the sky have names. You can see Sirius in the lower left, and Procyon and Canis Minor to the left, in the middle upper left. I've removed the art so we can just show the lines that say what are we suggesting to each other. And of course, these lines, again, are not actually in the sky, and neither are all these words and things. But what we do is we trace them out, and we help people understand where stars are in the sky. We tell stories using the tracings that we might place that we guide other people to, so we can associate them with the stories and mythology of the sky. And it's fun to draw them out for a friend or to when you're in an evening stargazing session and say, okay, start from Bellatrix and go right, and you'll see this little arc in the sky. That's the bow. And if you look below Bellatrix, you see 3 stars. That's like a belt. That's also like a belt. And there's the sword hanging down, and there's his 2 feet, Rigel and Saiph, and his 2 shoulders, Bellatrix, and Betelgeuse, and his head is those 3 stars at the top. And he's got an upraised club going up there. You know, you can make up all sorts of wonderful stories, and you have to point the stars out to people, otherwise they might not know which stars you're talking about. So the lines help. So today, though, constellations are much more codified. And constellations can be codified into these red lines. And those red lines were agreed upon by the International Astronomical Union a long time ago. And every star inside the box of those red lines that's on the sky. These aren't, again, real things, and they're just arbitrary demarcations on the sky so that we can say if we're looking at a star inside this box it's a star in Orion. So look up at the bow of Orion, and we see those two little stars that are above the row, or at least a bunch of little dim stars above the bow. Those stars are also in the constellation Orion. They're just not associated with any of the lines or the mythology or the stories of Orion. And we look at the horns of Taurus, the bull, and Aldebaran is one of the bright stars of the cluster, the Hyades cluster, a nearby star cluster. But all the other stars you see in that box that surrounds the Taurus's lines and Aldebaran's lines and off to the side Pleiades, they're all part of the constellation Taurus as well. These regions on the sky are now what we call the constellations, and they are agreed upon locations in the sky or regions in the sky. And there are 88 of them, and everyone in the world, every astronomer in the world agrees that these are they. And that helps us as scientists to understand the differences between all these locations in the sky. All right, so now let's actually look at the concept of the asterism. And let's do this again and look at the concept of an asterism. And we're looking at the constellation, the asterism of the Big Dipper. And the Big Dipper is, of course, off to the left there. And it looks like the familiar 7 stars of the Big Dipper. And if you don't know what you're looking for in there, they're the brightest 7 stars in the lower left-hand side. And the Little Dipper is in the upper right. And the Little Dipper is a little tricky to see, but I'm going to highlight it in just a second. The Big Dipper is part of the constellation Ursa Major, and the Little Dipper is part of the constellation Ursa Minor. And this is looking north on a late July night. So first what I'm going to do is I'm going to add the star names to the field of view. And the star names themselves, we have the all the bright stars in the Big Dipper have names, as well as the 3 brightest stars the names of the 3 brightest stars in the Little Dipper are also held. And there's Polaris, that's the North Star. It is not the brightest star in the sky. It just happens to be at the North Celestial Pole, which we'll get to shortly. Okay, so now what I'm going to do is I'm going to add the asterisms to show you the locations in the sky that we call asterisms. So the Little Dipper now is highlighted. We can see the stars of the Little Dipper, and we can see the stars of the Big Dipper. There's also an uncommonly used asterism that pops up in Stellarium called the Mini Dipper, which is off to the side of Dubhe. In the Big Dipper. The Big Dipper is typically thought of as those 7 stars, and the Mini Dipper is almost never thought about in terms of asterisms and thinking about. So it's a very rare thing to see. Anyway, let's actually now go along and add the constellation names, which are Ursa Major and Ursa Minor. Ursa Minor is the Little Bear, and Ursa Major is the Big Bear. And so that's their Latin names. And now then I'm going to add their International Astronomical Union constellation boundaries, which are those red lines we see in the sky. And finally, I'm going to now add the constellation lines for the constellations themselves. And I'm going to zoom out to show a little bit more. The constellation lines that we see here in the sky are the common things. There's Draco the Dragon, Cepheus, Cassiopeia, Camelopardus, Bootes the Hunter. There's only 2 lines for Canis Venatici, and Leo Minor, the Little Lion, has only that. So let's now look at the various mythological artwork that's associated with these. And there we have the Big Bear, Ursa Major, which is a big bear, and the little bear is upside down going the other way. Draco's a dragon. Cepheus is a seated king. We see Perseus rising in the east. And then we have the Arcturus, which is in the bottom of the foot, the kite of Bootes the Hunter. We have all these stories. There's the little lion, Leo Minor. And now we have a very, very, very busy sky. Just a really busy sky with all of this artwork and this constellations and everything that we see. So I'm going to now clean things up and just reduce it all the way down to what we see in the sky when we might want to point out to somebody what it looks like on a night sky. And that's our constellations that we think of that we might draw out to a friend or a companion under a stargazing session. but really none of that's there. And all we really get is this night sky, and hopefully we know the cardinal directions to N for north and then the northwest. And we see that Polaris was a star that's directly above the horizon. We can always find true north by looking for Polaris in the Little Dipper and then swinging east from there to get our azimuth angle. And our altitude of the Little Dipper will show us our latitude. I already said that. Oh, keep it going. All right, so this is just a wonderful thing that we see as we go through the night sky and you go outside. Hopefully you get to see something beautiful like this. These are not new things, and so this is a hand-colored engraving of Ursa Major by Johann Bayer, which appeared in the Uranometria in 1603, very close to the time that Kepler and Galileo were doing their work on the night sky. These pictures in the sky of the various and sundry creatures are different, and you can see Johann Bayer's image of Ursa Major makes that the tail is the three stars and the body is basically very little of it. But that's the Big Dipper is only the latter, is the haunches of the Big Bear. And we have all these other stars that are bright in the sky that we point out to find the constellation. And it were pictures like these that helped people try to understand locations in the sky and to map the sky mythology that people had been discussing for a long time. Now let's briefly look at the overview for this all. And what we have is, this is a free software, Stellarium again. And this is a night sky simulator, and you can see the settings across the bottom. And we're looking south at this point. Again, I'm going to try to show the sky from Boulder where I took that picture. Now it's just mid-August in 2023 as opposed to that, so we're missing Saturn from this field of view. And we're also, again, facing south by southwest. And as you can see by the cardinal-based directions across the horizon there. So I've added the constellation lines, as you can see, and that traces the common asterism that's the core of each constellation. And the Scorpius has the three prongs, and the heart of the scorpion is his raging heart, and there's a teapot for Sagittarius, and that's the asterism for those constellations. So now I'm going to go on and add in the names of the constellations. There's Sagittarius and Scorpius, Corona Australis. And we're also now going to start using a tool that'll show the angular separation from stars from the horizon. And what we're actually using is trying to say, well, how high off the horizon is a given star in Sagittarius? And so that particular star in Sagittarius has an altitude of approximately 20 degrees. And then we're going to look at other stars too, just to see. And I've got, in order to move around, I've got to give it a try. So I'm going to click on this individual star. And that star is going to be, say, this one, Nunki, which is also in Sagittarius. And I'm going to try getting the angular height off the horizon of that particular thing. And I've got to kind of swing it around just so it's going straight up from the horizon. And we can see it's approximately almost 23 degrees. And you can see that it has an azimuth angle. See the numbers way up in the left-hand corner of approximately 192 degrees, or just under 192 degrees. Means that we need to turn 192 degrees east from north to get to the horizon point directly below that star. Again, we had to turn 192 degrees east from north around the horizon to get to the point directly below that star on the horizon. Then we go up roughly 23 degrees in order to get to that star above the horizon. Now let's add the constellation boundaries in after we've done all this, because, why not do that? And because that's always fun to have those in. Let's see, there they are. And it's not completely important. Now I'm going to turn on the altitude and azimuth grid. And this is what we think of when we go outside and we're making believe that there's this dome over our head. And we're using these grid lines in order to get us to help us navigate the sky in this altitude and azimuth system. So each of the green lines is separated by 5 degrees on the grid. And notice they're all distorted squares. Notice each of the vertical lines comes straight up from the horizon. And now they seem to kind of bend and curve as we go around, but they all, if you face that direction, that exact direction, the line that you are facing is coming directly from the horizon, and it is 90 degrees from either direction on the horizon. So every one of those azimuth lines that comes up from the horizon is 90 degrees from the horizon. All of the lines going across are parallel to the horizon going up. So kind of funny looking because it's like, wait a second, the horizon's kind of flat at the bottom and it curves going up. It's like, yeah, because we project a dome on the sky, but all of those altitude lines are parallel to the horizon, and all of the azimuth lines come 90 degrees straight up from the horizon towards the zenith. And that trick of projection is, well, there's spherical trigonometry for you. So now then, let's swing around to the south and show off, let's try to show off the altitude and azimuth of some of these lines, just to prove it. I mean, we see the lines off to the side, 25 and so forth, and 10 and 20, but let's actually just go through and take that angle measurement. Okay, here we go, all the way over here, yep. And now I'm going to look at that star, or actually this line, and I'm going to drag from that line all the way down to the horizon, assuring that I have equidistant between those two azimuth angles, and we get those lines, and sure enough, it's that one was 20 and this one's 35. And so we're pretty confident that that's real. Okay, now we're going to swing around the horizon like we're standing in place, keeping our head level, and just turning around to face roughly northish. We kind of swing around a little bit too far, going east. And now we're going to look around. Oh, there's a Big Dipper again. We just were talking about that. And swinging around, there's Perseus. We were talking about that too. And we're going to swing all the way around back down to the south again. And we see that the altitude lines are again parallel to the horizon. Now, I'm going to widen the field of view. So I zoomed it out, so it's about 150 degrees field of view. And now how all the lines converge at the top. That's the zenith. That's where all the azimuth lines converge. And we see that Altair in Aquila is about 58 degrees up from the horizon at this date and on this time at this location. And Vega is all the way over there. See, there's our 58, 180 degrees roughly azimuth. And Lyra is approximately 270 degrees azimuth and 78 degrees off the horizon. But we can't go straight down in our field of view. We have to go straight down towards the horizon, the nearest point that Lyra is to the horizon. So we have to swing around and bring that all the way down. That's why I pulled it around to the right, because we have to go straight down to the horizon, such that the altitude is 90 degrees up from the horizon either way. The only way to properly measure where Lyra was along the horizon. So let's try to measure the angle on the sky of something that's an altitude line that's not directly on the horizon, like this. And we notice that we're not quite getting lined up with those things, because this is the shortest angle between these 2 points on the sky, which is not one of the altitude lines. Those altitude lines are parallel to the horizon. That's not the shortest angular separation between these two things, which the measuring tool is trying to show. Okay, so now we can go over to Hamal in Aries, and it has an azimuth angle of about 68 degrees, as you can see from the stats in the upper left. But if I naively measure the angle in the sky to the azimuth angle to north, I get it's too low by a few degrees. And that's because that we have to measure across the horizon. And when we finally do measure across the horizon to it, there's our 68 degrees, right? So that's what we see. Now, now we're going to go take a look and zoom in. I want to try to zoom in on the zenith. So let's go try to look at some stars at the zenith. But first we can say, where's the zenith at? Hey, all the way up there. It's like, yeah, we can go all the way up, and there's the zenith at approximately 90 degrees. Well, it's not a great measurement. So let's actually just kind of click on some stars and zoom in. There we go, and off I go. So we can see that I got to move it around a little bit, get it all centered up nicely. All right, so if we go all the way to the top and we're looking straight overhead, now we're on our backs looking straight up, trying to orient ourselves and see what stars are at the zenith. Well, the zenith stars change minute by minute, hour by hour. Now I'm going to zoom out and take in a full field of view. This is a whole sky in a circular projection. And you'd never see this. When you lie on your back and your peripheral view always extends to the horizon is always to your left and your right and above and down when you're lying on your back. So we don't see this unless you have extraordinarily bad tunnel vision and macular degeneration or some sort of eye disease. But I don't know if this is possible with such tunnel vision degenerative diseases, but maybe it is. But what's interesting about this particular projection is it shows everything that's in the sky at the same time. And that's kind of nice because it's hard to see all the sky at once. So this looks like just a map of everything that's in the sky at Boulder, Colorado on August 12th of 2023, right? That was what was in the sky at that time at that place. So that's pretty helpful. It helps us to make a map of what's in the sky. So now I'm going to try some things. I'm going to try maneuvering this around a bit. Maybe I can orient it better. But you can see that as you turn around, you're facing different directions. Maybe you're not facing true north. It's hard to make this thing face absolutely true north. But what now I'm going to do is I'm going to start skipping forward week by week. You can see the numbers go across on the bottom. But I'm keeping the time fixed at 11:20 p.m. local time. And each of these is a snapshot which repeats year after year into the same location on Earth. So we keep going forward and forward and forward. Now we're in 2024, 2025, and we can see that these patterns recur and recur. The only things that are going to be different are what's on the zenith at different days. So the stars change, which ones are at the top of the zenith at different days. And now I'm going to kind of go back and zoom out and face due north for just a second. And there's our familiar Ursa Minor again. Now, I'm deliberately showing Ursa Minor for a reason. Let's actually speed forward in time just like I was doing. And I'm going 1 week at a time. And as I do so, you see that the stars seem to rotate around that one star, Polaris. In Ursa Minor, that's the pole star. So we'll talk about that in another video on the celestial sphere. So let's just go back and take another look. This is one of those maps that we were talking about. If we look at the night sky in October, this was from nightsky.jpl.nasa.gov. You can certainly go there and download these things from them. This is free to download, and it's a good little map that shows you the biggest asterisms of the night sky. You can see that they highlight the Big Dipper, they highlight Cepheus, they highlight Cygnus the Swan, they highlight the Great Square of Pegasus, and they also show, oh my goodness, there's the teapot of Sagittarius too that we talked about, and the moon where it is, and where Jupiter is, and Saturn is in the sky, and of course the planets will move with respect to the background stars. But this kind of map will help you find the things in the sky that you see when you go out just to go stargazing. And you can either look at a more detailed map to get more detailed versions of these constellations and learn more of the constellation names that are in the sky, or you can just have fun trying to find these and take this out with you at about 9 p.m. or in late October, about 8 p.m. It'll change a little bit as time goes on, and things will rotate around the sky as we saw, but that's kind of what we're trying to help you do, is go outside on the night sky and have a proper little map like this and find the things that are there. So this time, we were just talking about the altitude and the azimuth, what the definition of zenith is, the horizon, that constellations are collections of stars, bright and dim, that can be part of some pattern or not, but are now one of 88 regions on the sky declared internationally by the International Astronomical Union that all astronomers and scientists use across the Earth. And the asterisms that we see in this thing are helpful little things to help us navigate a nice and wonderful evening stargazing.